In section 2.2, we look at graphs of functions. So let's recall that if f is a function with a particular domain A, the graph of the function is a set of ordered pairs. And those ordered pairs are x, f of x, where x belongs to the set A. That is to say, x is an element of the domain. And you plot those points in the coordinate plane. So basically, the graph is just the set of all points x, y, but remember y is equal to f of x. So a lot of times we use the notation x, f of x to represent our points. So as an example down here below, we have, some kind of a graph here, and this graph has a whole bunch of points on it. And each one of these points has an x-coordinate, which we call x, and a y-coordinate, which we call f of x. So just as a quick reminder, we say that x belongs to A. A is what we call the domain of the function, and f of x belongs to some set B, and B is the range of the function. Let's talk a little bit more about domain and range. So here we have an example of a function, f of x equals the square root of 9 minus x squared. I want to talk about the domain and the range, and we can do that from a couple of different angles. We can do it one way by simply algebraically figuring out the domain and range, and we can do it another way by looking at the graph of the function to help us figure out the domain and range. So let's remember that anytime you have a square root, whatever is inside the square root, which in this case is 9 minus x squared, that has to be greater than or equal to 0, because we don't want to take the square root of a negative number. There's actually a couple of different ways you can solve this. In the previous section, I showed you how to solve something similar to this by factoring. I'm going to show you a slightly different technique here. If I add x squared to both sides, we get 9 is greater than or equal to x squared, which is the same thing as saying x squared is less than or equal to 9. And then what we can do is we can take the square root of both sides. Now, when you do this, you have to remember that the square root of x squared is the absolute value of x. And the square root of 9, of course, is 3. So we end up with the absolute value of x is less than or equal to 3. And by the definition of absolute value, this means that x has to be a number in between positive 3 and negative 3. So this is our domain. Now for the range, you have to think this way. If you plug in all of these numbers for x in your domain, what kind of number are you going to get out of the function? And it's actually not that hard to think about. So again, we know that x belongs to the set of numbers between negative 3 and positive 3. So what's f of x going to be equal to? Well, if you consider x being 3, if you plug 3 in here, 9 minus 3 squared is going to be 0. 0 is going to be the lowest number that you can get for f of x, because you can't get a negative number. And the largest number that you're going to get in here is when x is the smallest possible value, and that's going to be when x is 0. Because if you plug in x equals 0, 9 minus 0 squared is 9, and then the square root of 9 is 3. So anytime x is a number between negative 3 and positive 3, f of x is going to be a number between 0 and 3. Now, I understand that some of you watching this right now will have a really hard time understanding what I just said. Another way to do this, though, is you can look at the graph of this function. So to do this, all we have to do is get some points. So I'll plug in x equals 3, I'll plug in x equals 2, x equals 0, x equals -1, and x equals negative 3. So I'm just plugging in some random numbers in between negative 3 and positive 3. Again, if I plug in x equals 3, we're going to get f of x is 0. You can do the math on that. If you plug in x equals 2, you're going to get 9 minus 2 squared. So that's going to be 5. And then you're going to have the square root of 5. And if you plug in 0, you get the square root of 9, which is 3. When you plug in negative 1, you get 9 minus negative 1 squared. Negative 1 squared is positive 1, and 9 minus 1 is 8. So we get the square root of 8. And if you plug in negative 3, you're going to get 9 minus 9, which is 0 again. Now, you can approximate these values on a calculator. The square root of 5 is about 2.2, and the square root of 8 is about 2.8. And if you plot these points, this is the graph that you will get. So here's what that graph looks like, and these points here represent the points that we have in our table. Now what I want you to notice is that this graph covers all values of x from negative 3 over to positive 3. You can see that there is a point on the curve covering all values of x between negative 3 and positive 3. So it's not too hard to see that x has to be in between those two numbers. And then for your range, you're looking at the same thing, but you're looking at the y values. This graph covers the values on the y-axis between 0 and positive 3. And so the range is all the y values in between 0 and 3. So when you have a graph of your function, it's much easier to identify your domain and your range. All right, let's talk about some special types of functions. Now, one of the most basic functions that we need to know for this class is the square function. The square function is nothing more than the function f of x is equal to x squared, and I'm sure many of you have graphed this function many times in the past. Now, you'll see a table of values here, and for convenience for this function, you'll notice that they put plus or minus in front of all these numbers. That's because when you plug in both positive 3 and negative 3, for example, when you square those numbers, they both give you positive 9. Because when you square the positive and when you square the negative, you get the same number, okay? And so for this reason, we simplify the table by saying that when you plug in positive or negative 1/2, you get 1/4. When you plug in positive or negative 1, you get positive 1, etc. Okay? And remember, all we're doing is we're just plugging those numbers into the function, right? So f of 1/2, is just 1/2 squared, and 1/2 squared means 1/2 times 1/2, and that's 1/4. And f of negative 1/2 is going to be negative 1/2 squared, and that is negative 1/2 times negative 1/2, which is also positive 1/4, for example. And if you plot these points, you get the very familiar graph that you see over here, and this graph, of course, is called a parabola. Now, one thing I want to point out real quick here is the domain for the function x squared is all real numbers. That is, you can plug in any number from negative infinity to positive infinity. However, the range for this function is not all real numbers. You see here on the graph that there are no negative values of y that are graphed. And that's because when you square a number, you don't get a negative number. So the range is going to be all those numbers from 0 to infinity, including 0. Let's take a look at the next function. So the next function I want to talk about is the cube function. The cube function is a lot like the square function, except that the power is a third power instead of a second power. And here you can see we've plugged in some various values of x, and here are the corresponding values of y. So all we're doing is we're taking our x value and we are cubing it, right? So 1/2 cubed is 1/8, 2 cubed is 8, etc., etc. And when you plot these points in the plane, you'll see that you get this kind of a graph. So on the right-hand side of the graph, it looks very much like the square graph. It's just a little bit steeper. But on the left side of the graph, instead of the parabola which went up here, you'll notice that it goes down. And that's because when you raise a negative number to an odd power, you get a negative number. Now, the domain for this function is once again all real numbers, so minus infinity to infinity. And the range for this function is also all real numbers. And that's because you can see quite clearly from the graph that this graph covers positive values of y and also negative values of y. So this is the cube function. And these basic functions that I'm showing you here, you should try to commit these functions to memory as much as possible because they come up all the time. Let's take a look at another. The next function that we want to look at is called the square root function. And the square root function is just the square root of x. Now, when you have the square root of x, you're not allowed to plug in negative numbers. So that's why in our table here, you only see positive values for x. And when you plug in those numbers, you're just going to take the square root of each of those. Now, of course, when you plug in a number like 2, you get the square root of 2. And to graph that, you would probably want to plug that into a calculator to get an approximation. But we can use these points here to give us a reasonable graph. And that's what you can see has been graphed here. Okay? So the square root function, if you notice, kind of looks like a sideways parabola. It's just missing the bottom half here. And that's because that's precisely what it is. It is a sideways parabola of sorts. Now notice the domain for this function is not all real numbers. The domain is from 0 to infinity because you are not allowed to plug in negative numbers. And also the range for this function will be from 0 to infinity because when you take square roots of positive numbers, you only get positive numbers. And so you can see this graph only covers positive values of x and positive values of y. The next function I want to look at is the absolute value function. So I'm sure you remember the absolute value of x in terms of a concept, but we want to talk about the function f of x equals the absolute value of x. So first, recall the definition of an absolute value. The definition of an absolute value is right here. The absolute value of x is basically just x if x is already a non-negative number. And the absolute value of x is the opposite of x if x is a negative number. Okay? So, for example, if I want to take the absolute value of -5, which I'm sure everyone knows is positive 5, the way you get that according to the definition is because -5 is a negative number, the absolute value of -5 is going to be the opposite of -5. So it's going to be negative, -5, which is positive 5. And then if you have something like the absolute value of positive 4, well, because 4 is already positive, there's no need to take the opposite, so that's just going to be 4. Well, if you make a table of values for the absolute value function, anytime you plug in a positive number, it's going to stay the same. Of course, the absolute value of 0 is 0, and anytime you plug in a negative number, you're going to take the opposite of that negative number. And if you look at those numbers on the graph here, you can see that you get this sort of V-shaped graph. And the domain of the absolute value function is all real numbers. You can plug in any number you want, but the range of the absolute value function is only going to be non-negative numbers. So it goes from 0 to infinity. Another concept I want to talk about is the vertical line test. So if you have some kind of a graph, the vertical line test will tell you whether that graph represents a function or not. Now remember, to be a function means that when you pick a particular value of x and you plug it into your function, you have to get a unique value of y. So on this graph here, you can see that when x is equal to a, because there's only one point on the graph corresponding to x equals a, that one point is y equals b. So this graph would represent a function because no matter what x value you pick, when you go up to the function, you're only getting a single value for y. Now what we're really doing here is we're just thinking about a vertical line, and if that vertical line hits the graph exactly one time, right, it cannot hit more than once, then it's a function. Okay, so the vertical line test says that if you have a curve in the coordinate plane, it's a function if and only if no vertical line intersects the curve more than once. So this first graph here is the graph of a function. But you'll notice in the second graph, quite easily, if you pick this particular value of x here, there are two values of y corresponding to that value of x. Okay, so there's a value of y here on the y-axis, and there's a value of y here on the y-axis. And because that one value of x has two different values for y, that is not a function. And what that basically means is that when you draw a vertical line, again, the vertical line test says you cannot hit the graph more than once if you have a function. So the fact that we hit this graph twice there means that it's not a function. So the vertical line test is a very quick and easy way to determine whether a graph represents a function or not. So as kind of a summary here, I just want to take a look at some important function classifications. So functions that look like f of x equals mx plus b, these are what we call linear functions. And that's basically when x is raised to the first power there. And the graphs of linear functions are lines, okay? Now, if your slope of your line is 0, it will be a flat line. But if the slope of your line is not 0, it will be some kind of a slanted line. And you talk a lot about linear functions in intermediate algebra, so you should have a pretty good grasp of those. The absolute value function we talked about a few minutes ago, that's f of x equals the absolute value of x, and this gives us our V-shaped graph. And then we talked about power functions. We talked about two particular examples of power functions. One is f of x equals x squared. The other is f of x equals x cubed. And so you'll recognize these graphs here as the ones that we talked about earlier. But you can also talk about x to the fourth power, x to the fifth power, x to the sixth power, seventh power, etc. And what you'll notice if you graph these is all of the even powers of x will look kind of similar. So notice that x squared graph looks very similar to the x to the fourth graph, a little bit different in the curvature, but they're both sort of U-shaped graphs. And if you were to graph x to the sixth power, it would also look similar. And then you should also notice that x to the third power and x to the fifth power look kind of similar to each other. And that's because those powers are odd powered functions, okay? So what we're talking about here as a general classification is the classification of power functions. And that's simply f of x equals x to the n power, where n is an integer, a positive integer. And then likewise, we can talk about root functions, such as the square root of x, the cube root of x, the fourth root of x, the fifth root of x, etc. And once again, you'll notice that the square root of x and the fourth root of x, those both look kind of similar to each other here. And then the third root of x and the fifth root of x look sort of similar to each other. Now, the reason the odd roots and the even roots look a little bit differently is because when you have an even root, you're not allowed to plug in a negative number. But when you have an odd root, you are allowed to plug in a negative number. And that's why you have a piece of the graph over here on the cube root function, but you do not have the piece of the graph over here on the square root function. So these are just some basic functions and some basic classifications of functions that you should know, because we'll be talking about these. We'll refer to these functions very often in this course.